Welcome to our deep dive into the controversial world of geoengineering. As the climate crisis looms larger than ever, innovative solutions are being proposed to combat its devastating effects. In this video, we will unravel the complexities of geoengineering, exploring its two primary categories: solar radiation management and carbon dioxide removal. Join us as we weigh the potential benefits against the significant risks, ethical concerns, and governance challenges, while also examining how the public perceives these bold efforts to reshape our planet's future. 1. Addressing climate change urgency. The urgency to address climate change has never been more pronounced. As emissions reduction efforts continue to fall short of targets, geoengineering is being explored as a potential tool to mitigate the impacts. It's like having a backup plan when your primary strategy isn't working. Scientists are racing against time, trying to find ways to prevent the planet from heating up further. The stakes are high, and the dependence on geoengineering is growing as a viable option to buy time while sustainable solutions catch up. 2. Two main categories. Geoengineering approaches generally fall into two categories: solar radiation management, SRM, and carbon dioxide removal, CDR. Think of SRM as an umbrella, shielding the Earth from the sun's intense rays, while CDR acts like a vacuum, sucking up the excess carbon dioxide from the atmosphere. These two strategies aim to tackle the problem from different angles, offering varied solutions to the climate crisis. Understanding these categories is crucial as each has its own set of methods, benefits, and challenges. 3. Solar radiation management, SRM. SRM techniques aim to reflect sunlight back into space, thereby cooling the planet. Imagine wearing a white shirt on a sunny day instead of a black one. It keeps you cooler by reflecting sunlight. Examples of SRM include stratospheric aerosol injection, where reflective particles are released into the upper atmosphere, and marine cloud brightening, which involves spraying seawater to create brighter clouds. These methods are like putting a mirror in space, sending some of the sun's heat away from Earth. 4. Carbon dioxide removal, CDR. CDR focuses on removing carbon dioxide from the atmosphere. It's like tidying up a cluttered room, making it more livable. Examples include afforestation and reforestation, bioenergy with carbon capture and storage, BECCS, and direct air capture, DAC. CDR addresses the root cause of climate change by removing greenhouse gases, aiming to restore balance to the Earth's atmosphere. These methods are vital as they attempt to tackle the problem directly rather than just masking the symptoms. 5. Potential benefits. Geoengineering, particularly SRM, could potentially provide rapid cooling effects and reduce some climate change impacts. It's akin to applying a quick fix to a leaky roof while planning a more permanent repair. CDR, on the other hand, addresses the root cause of climate change by removing greenhouse gases. The potential benefits are significant, offering hope for a cooler and more stable climate. These technologies could buy us valuable time to implement more sustainable solutions. 6. Significant risks. However, SRM techniques carry significant risks, including potential unintended consequences for weather patterns, ecosystems, and human health. It's like trying to fix a delicate watch with a hammer. The potential for causing more harm than good is real. CDR methods, while generally considered less risky, can be expensive and challenging to scale up. The risks associated with geoengineering cannot be ignored, and they highlight the need for cautious and informed decision-making. 7. Ethical concerns. Geoengineering raises complex ethical questions about who gets to control the Earth's climate. It's a bit like giving someone the keys to the world's thermostat. The potential for unequal impacts on different regions and populations is significant, raising issues of equity and justice. Who decides who benefits and who bears the costs? These ethical concerns are at the heart of the debate surrounding geoengineering, making it a contentious issue that requires global cooperation and agreement. 8. Governance challenges. There is currently no international framework governing geoengineering research or deployment. This lack of governance is akin to having no rules in a high-stakes game. Concerns about potential unilateral actions and lack of accountability are growing. Without clear guidelines and oversight, the risks of geoengineering could outweigh the benefits. Establishing a robust international framework is essential to ensure that these technologies are used responsibly and equitably. 9. Public perception and public opinion on geoengineering is divided. Some see it as a necessary tool, while others view it as a dangerous and unpredictable intervention in nature. It's like debating whether to use a parachute or build a safer plane. The division in public perception reflects the broader uncertainties and concerns about geoengineering's implications. Building public trust and understanding is crucial for any future deployment of these technologies. 10. Research and development. While some small-scale field experiments have been conducted, geoengineering research is still in its early stages. It's like being in the early chapters of a complex novel, with much of the story yet to unfold. More research is needed to understand the potential benefits, risks, and ethical implications of these technologies. The journey ahead is long and fraught with challenges, but it also holds the promise of innovative solutions to one of humanity's greatest challenges.